Okay, good afternoon, one and all. So we are going to start our today's lecture, but I think today is the very less attendance is there. Only 8 students are there in the classroom. I don't know where are the remaining students. So it is a request to you all once again. You kindly enter the room with your proper division, roll number, and again your first name and last name. Okay. So I request you all once again. So there are some students who are trying to log in with only first name and second name. Okay. So kindly take the note of this and follow the proper instructions. Okay. So we start our today's lecture. I hope that everyone is getting my voice and again video and again okay, I have shared screen also. Okay. So we'll see in the previous lecture we have covered okay, we have completed the first chapter, and after that we have gone for a class test. The 20 marks class test I have conducted in the last lecture, is in the yesterday's lecture. Okay, so still I have not assessed it. So maybe tomorrow you will be getting the marks of the first class test here. Okay. So already we have started the second chapter. Okay. So the name of the second chapter is block cipher and data encryption standard. So this is the next part of the first chapter itself. Okay. See what I am telling here. So the name of the first chapter was symmetric ciphers. Okay. So the next part of that symmetric cipher we are going to study into the second chapter. Okay, you can you remember this one, the symmetric cipher. This is the name of the first chapter, and block cipher and again data encryption standard. Okay, so this is a part of the first chapter. Okay, that is called as the block cipher and data encryption standard. So I told you that what is the symmetric cipher. So the symmetric cipher is nothing but the only one key we are going to use at the sender side and again as well as the receiver side. Okay, that key is called as the secret key. So this is the logic behind the symmetric cipher. In the second chapter also, whatever the algorithms we are going to study, all the algorithms, they are belongs to the symmetric ciphers technique. Okay, so here in this chapter, whatever the algorithms are there, all the algorithms, they are having the only one key. Okay, that is a shared secret key is there. So the only one key we are going to use. Okay, so in case of the block cipher and data encryption, a standard here. Okay, you remember this one. That's why I'm saying this one. The second chapter is part of the first chapter. Okay, here in the second chapter also we are going to learn the concept of the symmetric ciphers here. Okay. So the name of the chapter is the block cipher and data encryption standard. And already we have seen that what is the syllabus of the chapter. So the syllabus of the chapter is the simplified DES. Again, the block zipper principles, the data encryption standard, the strength of DES. Again, differential and linear cryptanalysis, block cipher design principles. Again, block cipher mode of operation. So these are the syllabus of the first chapter, and book for this chapter is the William Stallings Cryptography and Network Security Principles and Practices, and Pearson Education publication is there. Okay. So these are the assignment questions. Already we have covered in the previous lecture. And what is the meaning or what is the title of the chapter? Okay, as per the requirement of a triple B. The block. So the block is nothing but this is the piece, or you can say this is the part. And cipher is that in the cryptography, a cipher or cipher is an algorithm for performing encryption or decryption. So now we know that what is the encryption and again what is the decryption. Okay. So now we are able to define so what is the encryption and again the decryption. And also we know that the data. So what is the meaning of a data here? Okay. So the data are characteristics or information, usually numeric, that are collected through the observation. So the any kind of the data you can consider. And the encryption is that the coding means the conversion of plain text into the cipher text. That is called as the encryption. And again, the decryption is the vice versa, the exact reverse of the encryption. That is called as the decryption. Means the converting cipher text into the plain text. That is called as the decryption. Now, last one is the standard. So what is the standard here? A level of quality. Okay, we need to achieve the quality. So here we are going to consider the quality means the related to the security. Okay, the any algorithm is having the good quality means it is going to provide the more and more security. Okay, that is called as the level of quality here. Okay. And about central idea of the chapter is that as per the requirement of triple B. So this chapter includes the detailed study of simplified DES algorithm. Simply DES is the short form of the data encryption standard. Okay. And the data encryption standard algorithm. Okay. So there are two algorithms are there. Okay. So here also again and again I'm going to say that simplified DES algorithm is different. And the only data encryption standard algorithm is the different are there. Okay, there are two algorithms which are called as the simplified means so the only you can consider the yes. Okay, yes DES and the data encryption standard. So here I want to mention this one. So what is the you can see that. So yes DES. Okay, this is the first algorithm, and second one is that only DES. So the SDES is called as the simplified data encryption standard. Okay, simplified data encryption standard, and the only DS is that. So this is the only data encryption standard. Okay, this is the data encryption standard here. Means the working style of these algorithms is a totally different one. Okay. So you should have to remember this one. So what exactly it is there? The once again, I am going to tell you that the SDS algorithm is the different one. Okay. That is SDS is called as the Simplified Data Encryption Standard. And the DES is only called as the Data Encryption Standard here. Okay, you remember this one? So there are two types of the algorithms. One is the SDS and again second one is the DES. Okay. And also we are going to study the differential and linear cryptanalysis and various types of block cipher mode of operation. Okay, when we are going to start the actual syllabus of this chapter, then we are going to study the detailed concepts. Okay, so this is the central idea of the chapter. Okay, so this chapter includes the detailed study of simplified DES algorithm and the data encryption standard algorithm. Also, we are going to study the differential and linear cryptanalysis and various types of block cipher mode of operation. Okay, there are total 5 block cipher mode of operation are there. So how they are going to see with the help of the diagrams. Okay. So the next point is about the importance of the chapter in subject syllabus as per the requirement of triple PE. So a block cipher is so I will tell you, okay, at the time of when you are going to start our syllabus, okay, at that time I will tell that what is the block cipher. So block cipher is an encryption or decryption scheme in which a block of plain text is treated as a whole and used to produce a cipher text block of equal length. So the data encryption standard has been the most widely used encryption algorithm until recently. Okay, in the recently means in our today's computer era, so the DES algorithm has been used widely. Okay, so we are having the most of the applications using the data encryption standard algorithm. So that is why we are going to learn this chapter here. Okay, this is the basic, the importance of the chapter. Okay, why we are going to study this one. Okay, so it exhibits the classic fiscal structure. So it is going to use the classic fiscal structure. So what is the fiscal here? So the fiscal is the name of the scientist who has invented one structure here. Okay, that structure also we are going to study in this chapter. Okay, about the fiscal structure. And DES uses a 64-bit block and a 56-bit key here. Okay, so at a time it is going to accept the 64-bit plain text along with a 56-bit key here. So that's why what I'm want to tell you here from this one, from this. So the DES algorithm is going to provide the more and more security. So the complexity level of the algorithm is the very high. Okay, whenever such algorithms they are having the very high complexity, then definitely they are going to provide the more security here. Okay, remember this one always. If the complexity of the any algorithm is the very low, suppose you can take the Caesar cipher, suppose you can take the Playfair cipher, there we are not going to find the any complexity level there. Okay, within a single step or the second step we are getting the results there. But here in this case, the data encryption standard algorithm, we will not get the result easily. The very high calculations are there. It requires the 1 day or 2 days. Okay, for getting that kind of the results. So that's why this DES algorithm is the very standard, and it is it provides the high security. That's why we are going to learn the second chapter here. Okay. And chapter objectives and outcomes here. So what are the chapter objectives and outcomes here? So the chapter objectives are that students will learn different types of block cipher principles, and students will learn the working of data encryption standard algorithm, and students will learn the various types of block cipher modes of operation and outcomes. So at the end of this chapter, what the students will get? So the students will be able to differentiate block cipher principles. So the students will be able to analyze the DES algorithm, and students will be able to analyze the block cipher modes of operation here. So the main CO1 is mapped for this chapter here. Okay. So these are the chapter objectives and outcomes here. Okay. So I will close this and I will open the syllabus point here. So here we are going to learn the actual syllabus point of this chapter here. So the first of all, I will tell that what is the block ciphers. Okay, this is the first definition we are going to see here. So what are the block ciphers? So just I want to differentiate what we did in the first chapter and what we are going to learn into the second chapter here. So can you tell me that what we have studied in the first chapter there? So you can see that in the first chapter, we have studied the different algorithms. Very easy algorithms were there. Substitution cipher and substitution technique, and again the transposition technique, and again the rotor machines. So there we are going to have the only one letter at a time. We are going to have the encryption, and the only one letter at a time we are going to have the decryption of that cipher text. But suppose if I have the huge amount of data, okay, if suppose I have the huge amount of data, then how you are going to have the encryption? Because if I'm going to use the only one character at a time, then it will take the more and more time here. So I have to reduce that time, and simultaneously I need to achieve the high level of security. Okay, that's why we are going to learn the block ciphers here. So what we are going to do in the block cipher here? See, at a time, multiple letters we are going to do the encryption, and the multiple cipher text we are going to do the decryption here. So that is called as the block ciphers. Means here we are going to do the here we are going to make the blocks of the plain text. Suppose the block is the I am going to perform the encryption with the input plain text are 50 characters at a time. So I can say that the 50 is a block cipher here. Suppose I can take the 60 characters at a time. Then I can say that the 60 characters or the 60 group of the characters, it is called as a block here. Okay. So this is called as the block ciphers. So you remember this one, the block ciphers are nothing but at a time the number of characters or the number of plain text characters we are going to consider for encryption. So that is called as the block here. So the encrypt data one block at a time means at a time we are going to have the encryption of one block at a time. And it is used in broader range of applications. So where the large amount of the database is there, so the large amount of the information is there. So at that time we are going to use such kinds of the block ciphers. Okay. Now the typical block size is a 64 to 128 bits. Okay. Now whatever the algorithms are there in the market, so the typical size is we are going to use the 64 to 128 bits here. Okay. And normal also the 8-bit is also there. Okay, what I told you that DES, simplified data encryption standard algorithm is there, no? That algorithm it is going to use the only 8 bits. Okay, that is also there. It depends on that particular algorithm, okay, how much it is going to accept. See here we have the different 2-3 algorithms are there. We'll see that how much they are going to accept. Okay. So the most algorithms based on a structure referred to as crystal block cipher. See how that block cipher is going to work. The crystal have defined one structure. Okay, that structure is called as the crystal block cipher. Okay, he has invented the crystal block cipher. How the inputs he is going to provide, what internally it is going to happen, with which functions he is going to use. Okay, all the things are there in case of the block cipher here. Okay. So the data encryption standard. See, we are going to learn the first of all data encryption standard conditions, and in that we are going to learn the first of all a simplified data encryption standard here. Okay. So the simplified DES. Okay, this is called as the DES. Okay, remember this one. Many times it is asked for the MCQ also. The DES stands for Simplified Data Encryption Standard here. Okay, this cipher using principles of DES. Okay, whatever this DES algorithm is there, this algorithm is going to use the principles of data encryption standard here. And it is developed for education, not real world use. Okay, so this algorithm is the that much complexity level is not high. Okay, you can say the low level or up to the medium level. Okay, it doesn't provide that much security. So this is the very easy algorithm is there. And the DES encryption algorithm takes an 8-bit block of plain text. So I told you that. So the block cipher. Okay, so here we are going to consider whatever the DES encryption algorithm is there. It is going to accept the 8-bit block of a plain text here. Means the bits we are going to consider 0 and 1 combination here. Okay, so the binary data is there. For example, you can say that 8-bit of plain text means 10111101. So how many total are there? So the total 1, 2, 3, 4, 5, 6, 7, 8. So the total 8 bits are there. So you can say that this is the one block here. Okay. So the DES algorithm is going to accept at a time one block, and that block size is the 8-bit here, and a 10-bit key as input. So along with this plain text, it is going to accept the 10-bit key here, okay, as input, and produces an 8-bit block of the cipher text. Okay, remember this one. How much block of the plain text you are going to provide, the same size of the cipher text you will be getting there. Okay, suppose you are going to provide the 8-bit of the plain text, then definitely the size of the cipher text must be the 8-bit cipher text. Okay, so the DES decryption algorithm takes an again 8-bit block of cipher text and the same 10-bit key yield to produce that cipher text as input and produces the original 8-bit block of plain text here. Here means whatever the DES algorithm is there. So the DES algorithm, it is going to accept the 8-bit plain text along with 10-bit key here. So that whatever the 10-bit key is there, it is common for the encryption as well as for the decryption here. Okay. So the 10-bit, it is nothing but it is a shared secret key, which is common for sender side as well as for the receiver side. Why it is common? Because we are learning the symmetric ciphers here. Okay. So many times I told you that the symmetric ciphers are nothing but the shared secret key is common at the sender side as well as the receiver side, because the sender has to perform the encryption process and the receiver has to perform the decryption process here. So you remember these things here because these are the many MCQ questions are there. So the first MCQ is that. So the SDES stands for, the SDES is called as the Simplified Data Encryption Standard. And the block size in the SDES is the 8-bit. And the size of the key is 10-bit here. The size of the cipher text is also the 8-bit. Okay. Why it is because 8 bits here? Because the any algorithm is going to accept the any size of the block here. The same size of the block it is going to produce as a cipher text here. Okay. Means here in case of the SDES, it is going to accept the 8-bit plain text and it is going to produce the 8-bit as a cipher text here. Okay. Now the size input, that is the plain text block, is the 8 bits. Output, that is the cipher text block, is the 8 bits. And the size of the key is the 10 bits here. And here we are going to consider the 2 rounds here. So why we are going to consider the rounds here? Because if you are going to have the multiple rounds here, then the complexity level is going to high here. Okay. So for getting the more security, we are going to have the rounds here. So you can increase the number of rounds here, no problem for that. Okay. At the sender side, you can take the 4 rounds, and the same rounds again we need to take at the receiver side here. Okay. Suppose in the encryption, we are going to use the 4 rounds here. So the same number of rounds we need to take into the decryption process here. Okay. And the round key is generated using permutations and left shifts. We know about the permutations and the combinations. So we'll see that in the example. So next we have the diagram and again the example. And encryption, it follows the initial permutation, round function, and again the switch follows here. And the decryption, again the vice versa of this encryption is that same as encryption except round key used in opposite order. So this is the SDES algorithm. Okay, this is the diagram here. So I will provide the 2 minutes time here. So you all take the diagram here. This is very important. So here just you can observe the SDS algorithm. So this diagram is very important here. Okay, that's why I given the time to you all. Okay, so one side it is having how we are going to do the encryption. Okay, so this is the first. You can say this is the first column, and again the second column. Okay, and again the third column here. So in the encryption process, so the downward arrows are there. The 10-bit key is there in middle, and again the last one is the decryption process is there. Okay, the encryption is going to execute at the sender side, and the decryption is going to execute at the receiver side here. And in between whatever the 10-bit key is there, the 10-bit key is the common to the as well as encryption, and again for the decryption also here. Okay. So if you can see the 8-bit plain text is going to take, and it is going to provide the 8-bit as a cipher text in the encryption. And in the decryption, it is going to take the 8-bit cipher text, and it is going to provide the 8-bit plain text here. And the 10-bit key it is going to accept, and the actual size of the key K1 is the 8-bit, and the key K2 is the 8-bit here. Okay, I will tell you that why it is going to take the 10-bit key as the input, and at actual time it is going to take give the only 8-bit key here. Okay, so the first of all I will tell you that what are these notations here. So this is the encryption, this is the 8-bit plain text, this is the IP. So the IP is called as the initial permutations here. Okay, so what are the initial permutations here? So the initial permutations are nothing but you know about the permutations. Okay, the permutation and again the combination. Suppose I have the ABC, then how many ways I can write it? The A, B, and again the C here. So I can write it the ABC, CBA, BAC, CAB, okay, CBA. In that way you can write. So these are the called as the initial permutations. So I'm going to take the initial permutation of this 8-bit plain text here. After that, FK. So some in the notebook you can write it. What I am telling here. So the IP is nothing but the initial permutations, and the FK is called as the complex function. Okay. So what exactly is going to happen in the FK, that we will see. The FK is nothing but the complex function, and the SW. So what is the SW here? So the SW is called as the switch function. Okay, the SW is called as the switch function here, and the FK again FK. Okay, again FK is the same FK is there. Okay. One more time we are going to increase the round level here. So we saw that the rounds are 2 here. So here you can see here the rounds are 2. Okay, and also I told you that the number of rounds you can increase, no problem for that. If you are going to increase the number of rounds here, then we are going to increase the complexity level of the algorithm. Okay, so that's why this FK is there again. That is the complex function, and again the IP inverse. So inverse of the initial permutation. Okay, this is the IP, and again this is the inverse of the initial permutations here. Okay, so see whatever these steps we are going to follow at the encryption, exact reverse of this we are going to follow at the decryption process here. So here we are going to consider that 8-bit as a cipher text to the initial permutation. Again the FK is the complex function. It is going to accept the key K2. Again we have the switch function. Again we have the complex function key K1 along with that. Again finally we have the inverse of the initial permutation, so that the receiver will get the 8-bit as a plain text here. Okay, so in this FK, so the initial after getting the initial permutations, and we have the FK here, that is the complex function. So what happens inside the complex function? See, we are getting the 8-bit as a plain text, and from this we are getting the 8-bit as a key K1 here. So we are having the any kind of the operation. Suppose OR operation is there, and operations are there. Okay, and we are getting the result here. That result again we are going to forward it to the switch function. So what is the switch function here? So the switch function is nothing but we are going to swap the values. Okay, we are going to swap the values from the left to right, and again from the right to left here. And again the FK, again in the FK we are going to have the OR operation with the output of the SW and along with the key K2 here. Okay, we are getting the result, and that result is going to forward to the IP inverse here. Okay, means the whatever the same functions are there, same functionality we are going to apply in the decryption also. Okay, and how the 10-bit key we are going to generate the 8-bit key here. So here we have the again notations you note down here. So the P10. So the P10 is called as the, first of all we have to go for the 10-bit key permutations. Okay. After that we need to use the shift operation from the left to right. Okay. We are going to shift the values here, and after that we are going to select the only 8 values here. So why it is we are going to consider the 10-bit key, and from the 10-bit key we are going to have the only 8-bit keys are there, because we need to improve the complexity level of this algorithm. So if the hacker is trying to get the values here, then what the hacker will do here? So it is going to accept the 10-bit key, means the everywhere it is going to accept the 10-bit key here. Okay, the hacker will remain in that assumption, so that easily he will not hack this algorithm. Okay, for that purpose, for increasing the security level of this algorithm, we are going to consider the initially 10-bit key, and at the actual use of this key is the only 8-bit keys are there. Okay, out of the 10-bit you can choose the any 8-bits key here. Okay, and the output of the shift value again we are going to take for the second key K2 here. Again there we are going to follow the shifting operation, means we are going to shift the left bit to the right bit like that. Okay, and again we have the P8. So what is the meaning of the P8 here? Again the permutations of that 8-bit, and any one permutation combination we are going to choose as the key K2 here. Okay, so this algorithm is the very easy, how we are going to have the permutations and again the combinations. But before seeing actual that, first of all we should know that what are the different notations are there. Okay, so once again I will explain you what are the different notations. So the 8-bit plain text, this is the actual your message is there. So the plain text is nothing but your message. Okay, and the encryption is that the 8-bit plain text we are going to convert into the 8-bit cipher text. Okay, so the input as 8-bit plain text and output as a 8-bit cipher text here. So the IP is the initial permutation, FK is the complex function, SW is the switch function, FK is the complex function, and again the IP inverse, that is the inverse of the initial permutation. Again at the decryption side, so what is the decryption here? The conversion of a cipher text into the plain text, that is called as the decryption here. So in case of the decryption, we are going to have the first of all IP, initial permutations, FK is the complex function, SW is the switch function, FK is again complex function, again with the inverse of the initial permutation. But for performing this encryption and again for the decryption, we are going to use the 10-bit key here. So the 10-bit key, we are having the first of all the permutations of the 10 bits. Again, we are going to follow the shift operation from the left to right shift. Again, we are having the P8. Again, we are going to choose the 8-bit keys, and on that 8-bit chosen keys, we are going to follow the permutations. And output of that P8, we are going to consider as the only key K1 here. So the output of the shift operation, again, we are going to forward it to the next level here. Again, there we are going to have the shift operation. After that, we have the P8. That is the permutation on 8 bits. And any one P8 permutations we are going to consider as the key K2 here. That key K2 is given to the complex function at the encryption as well as for the decryption here. So in that way, this is the simplified DES algorithm. It is going to work here. Okay. So here it is given as the one example of the IP. Suppose the IP is the 263.14857, and the IP inverse is one combination we have taken here. 4135728 Okay, this is the bit locations are there. Okay, the every order is there 1 2 3 4 5 6 7 8. Here also 1 2 3 4 5 6 7 8. Okay, the 8 bits are there. Now here is the how the SDS key generation it is going to happen here. Okay, what see whatever we are having this diagram here. Okay, this internally how this key generation is going to work. Okay, that is shown here. This is the key generation for simplified DES. Okay, just I will provide the 2 minutes time here. You just note down this diagram here. This is the very important. So this diagram is for how the SDS key generation is going to process here. So we have the 10-bit key here. So this is the 10. So the numbers indicates in the diagram that is the bits, how many bits are there. So the P10 is nothing but the permutations of the 10 bits. So this is the permutation order we have taken here. So in the yellow strip you can see here, this is the permutation order. The 1, 2, 3, 4, 5, again the 6, 7, 8, 9, 10. Okay. So this permutation order we have chosen here. And this It is divided into the two groups here. One is the 5 bits, another one is the 5 bits. And on that 5 bits, we have followed the left circular here. Okay. From the left bit, we are going to shift it to the right. That is the ls minus 1. The only one bit we have shifted here. Again, the ls minus 1 on the second half. The only one bit we have shifted from the left to right here. So output of this ls minus 1 we have taken for the next iteration. Again, this ls minus 1 we have taken for the next iteration. And these ls minus 1, these ls minus 1 we have combined here, and we form the P8 here. Okay. So the sequence for the P8 is that 6, 3, 7, 4, 8, 5, 10, and again the 9. So the only 8 bits we have considered here, so that it becomes as the key K1, which is the 8 bit. Here also again we have the ls minus 2, ls minus 2, again the 5 bits. Out of that we have chosen as the key K2 here of the 8-bit size here. Okay. So in that way we have generated the 2 bits here. One is the key K1 and again the key K2 here. So in the examination, you have to remember, so what is the input for the SDS key generation? 10 bit. What is the key size of the key K1 in SDS? 8 bit. What is the key size of the K2 in SDS? 8 bit. Okay. You should remember all these kinds of the aspects in the examination. Okay. So this is the key generation for simplified DES algorithm. And this is internal structure is there. Okay. How exactly it is going to happen in case of the SDS encryption details. Okay. So I think today is the time it is over. Okay. So I think here we will stop here. Okay. So the remaining points we will cover into the next lecture. Okay. So I request you all, you please drop your attendance. So I'm going to enable the chat window here. So I request you all, please put your attendance.